Hello everybody, welcome back. Now today I have quite a lot of new uh, settings suggested by my friend who used to stream. So I'd like to take a look. Well, hold up a second. 2500 kilobytes. It should be at least 4,000. Okay. I don't know. I don't have very much the idea of how precisely all of this stuff works. I'm a programmer, not an system engineer so far. So that should be fine. Let me take my cover because my my heating system doesn't work. So my room is like 17 to 18 degrees, and I'm used to cold, but god fucking damn it, this is way too much cold. I have to remember to page my to call my tenant. It's way too crazy. Meanwhile, I have been reading the docs on my own, and I regret haven't read them. So thank you, Linux. As a general tip, I think that the idea of taking a good read to most before you go out and try to do exercises is probably better. I used to just love the idea of winging it and see where it goes, but after a while it will be always bad. So I would like waste hours trying to understand something that I could have read years ago. So there's no real advantage over that. So error 4. Okay, I remember this last time. I actually gave a quick look. I wouldn't say quick look. I actually read it. Read it. Dude, read is the worst verb to know. Like, what in the shit do you mean it's the same thing but you read it differently? You have no idea. Italian is very different from English. So all of this dictation is simply not happening. Neither in Italian, nor in Romanian, nor in Russian. So it takes some time to get there. Yesterday I got up to generics. So weird error handling. Let's take a look what this wanted to be. So the right partially equal. The trait partially equal. Take a look. RHS sized self require method. Equal, not equal. Okay, fair. It is what it feels like. Also creating error. Should check. Well, my audio is being registered, so I'm guessing something going out. The right partial equal, the bug struck positive integer. I just hope I'm not very ahead. Alright. I just hope I'm not very ahead now that I fix it. Struct positive not integer, implement positive non-zero integer. Function new. result self creation error. To do this function shouldn't always return on OK. Alright. Self value as U64. But can we err? In some case, like, does value have something like to, does as fail some way? Doesn't look like it. Oh, right, if it's negative. So if value is less than 0, should be none. It should be error. This one. Creation error. Expected value found in a right. So the enum thing. So it be like 0. Actually negative. Value is 0. Return R. Okay, so this is the exercise that I'm doing in a IMBA way, but it's like a pattern matching kind of situation. It'd be like value dot match, and should be creation negative 0 and everything else, which means that the self should go here. Now makes me wonder. Actually, no, hold up. This is the deal. Here goes the error. Send sign. God damn it. What do you mean? Here goes the error. You don't need it. Good. And this is yeah, wait a second. And check match and less than 0 rust. There you go. So value dot compare with 0. Ordering less. How does he know? Ordering equal to 0. Now, can I borrow it for the love of God? So he wants me to... standard compare ordering. What more do you want? Of course, I don't need the return. There you go. This feels more Rust-like. Feels better to me. Ordering less equal greater. Now, why would I type all of that when I can say in any other case just get it up? But at least I understood the idea from the Rust. From the how would someone who use Rust read it? And honestly, it feels kind of good. Again, I'm hating the fact that Rust feels great. I don't want to be in the church, okay? I simply don't want to. It's like it's going to be way too dang to be in the. Oh, I'm a Rust developer. These guys are way too hard on themselves and everybody else. Alright. This exercise is altered version of error 4. By the way, let's make a little bit more space. Yeah, let's give it the whole length. This exercise is an altered version of errors 4. Use some concept from we won't get until later in the course, like box and the from trait. Dude, I've read it. I got them. Say less. The box, however, I wish to take a look again because there's something like called din. Alright. Which the compiler told me beforehand that you have to say like a result box din or some shit like that, you know? It used to be. Sorry about that. Yeah, couldn't the bears not respond to messages? Okay. Which means that this is going to be like a generic error, which last time I was trying to achieve. The result didn't, but the compiler suggested that. And I think that's a better idea to just make it as generic as possible. Because in my understanding, this is a generic error. Whatever here goes, it should be a din from the error, which, by the way, din is a keyword. Rust API. You should be take. Oh, thank you, Mari. Thank you for the follow. Yeah, anyway, so we saying din. That's the keyword. Din is a prefix of a trait object type. The DIN keywords used to highlight the calls and methods associated trait are dynamically dispatched. To use a trait this way, it must be objectively safe. Okay, so it's the same thing as implements a specific trait, but instead it's dynamically dispatched, which I don't know what it means. Suppose I which implementation polymorphic operation to call at runtime. Okay, so unlike traits and in general, say traits and generics, this one gets implemented at runtime rather than that swapping thing, swapping metamorphosis that he does at the compiling time. So with this a better idea, we can go and finish the error handling. This exercise is an altered version of errors 4 exercise. It uses some concepts that we won't get to until later in the course, like box and trait. From trait. It's not important to understand them in detail right now, but you can read ahead if you like. For now, think of a box type as I want anything that does type. In short, this particular use case for the boxes is for when you want to own a value that you only care that is a type which implements a particular trait. So the box is declared of a type boxed in trait, where trait is a trait that the compiler looks for on any value used in that context. For this exercise, that context is the potential error which can be returned as a result. Which, by the way, I struggle to see the difference between interfaces because I've worked in Java a little bit. So even with generics, you can pass the same function, even without generics actually, you can pass the same function where it has the same interface and use it in similar ways. So that should be very similar to what happens here. The Rust book tells me that it's not that, it's different. And yes, you can specify what interfaces it implements, which is nice because now I don't have to take a look at the initial class to understand what's happening. I always love to understand what's going on from where am I instead of snipping to code. That's the greatest thing ever. I have to have everything. I don't have to, but it's way easier to understand the code if the code is there and it's doing something in your face. Which is weird for Rust because there's a lot of implicit behavior. So Rust is going to be very implicit in some cases, and going to be not implicit at all in some cases. Just feels inconsistent. Right, so we import the standard error. We import the fmt package format. Yeah. Same problem as before. This time, this is required so that creation error can implement error. All right, so implements the display trait for creation error, which is my enum error. Function format, which will take himself without borrowing, and a mutable reference to the formatter. So you actually don't go to sleep, Kira, huh? Mutable formatter. What the fuck is a formatter? Flag, fill, align with precision. Configuration for formatting. A formatter represents various options related to formatting. Good enough. You can return a formatted result. I don't understand why it has to be a formatted result. Right, so creation negative, creation, let description match self. All right. And function write string description. Okay, good. So we're going to take based on the value, write the description and return with the formatted string. I don't know if I like it more just to return the formatted string, but fine. Implement error for creation error, derive partially equal debug, struct positive non-zero integer. So this is what the book page will tell you to try and put everything inside the trait, rather than have to put your checks inside the trait rather than having them swimming around, so you don't have to copy that much. Sir, I think I will copy anyway, but thank you for the suggestion. Function new value I64 result positive non-zero integer. Thank you very much. That was bugging me on the inside. You can just type the non is going to be capital, but the zero not. Come on, man. Okay, so match value x if x is less than 0. Fuck is x? Now this is bizarre. I was trying to find something like this instead of typing always that creation, that ordering class, ordering trait, ordering struct. God damn it. Type x. Okay, positive non-integer as x as u64. Good. This is fine. This is going to be formatted. Nice. Add the correct return type result boxed in. What we can use this? Yeah. So this is going to be very simply a result with any expression as a return and a box that contains any kind of creation. But I can say it gets any type of error. So it took so long to read everything else, but the exercise was basically done. Sol 13.5. Which is going to be, yes, box to generic output. Let me uncourse this one as well. No bad stuff should be implemented. There you go. It probably doesn't matter because it will automatically override it, but it's for the soul. By the way, this automatic overriding, dude, this has to be somewhere, right? Target, I guess. Debug. Oh. Possibly not. Stop. Don't edit the solution file. I want to take a look at the project later on, perhaps. Alrighty, so using catch-all error types like boxed-in error isn't recommended for library code where coders might want to make decision based on the error content instead of printing it out or propagating it further. Here we define a custom error type to make it possible for coders to decide what to do next when our function returns an error. So use standard number parse int error. Derive parse equals, sure. Custom type that we will be using in positive non-zero integer parse, dude. It's driving me crazy. Stop calling it bad. You know what? Fuck it. I'm not yielding. Creation error. Parse int error. Positive non-zero. Function from creation error self creation error. Okay. Add another conversion here. Sure, which would be the same thing, but instead of creation, should be parse int and should work wonders. From parse. My bad. Now hold up a second. God damn it. Now hold your horses. It doesn't work, but never mind that. Does Rust want underscores or does want what you call it? Yeah, Rust usually would white. Camel case. Why is this function snake case specifically? Don't quite get. Well, anyway. I want to make some PRs to this repo. Implement struct positive non-zero. Implement positive zero. So this is the same thing as before. Function parse. Result self parse non-positive error. So change this to return an appropriate error instead of panicking when parse returns an error. Is here that we put it? 9. Put it behind this. 9. So those are the testers. Yeah. Because we are unwrapping. And unwrapping is evil. Type its match resolving I64 as from string error parse non-zero expected parse int error found parse non-zero errors. Now can I plus it? Or can I OR it? As from string error positive non-zero expected parse int error found positive non-zero. Yeah, doesn't this mean and use the complete version of positive and zero from the previous example. Below the line to do, ask we change this example using the map error method on result from type intro. Try using something similar to result from parse. You can use the a present to return value. Yeah, but this means that I fucked up beforehand. Should mean that. Like here. So from parse is self and it's going to be self parse int error. This feels like what you would want it to be. Wouldn't it? That means what? Resolving I as from error parse found parse was 0. Yeah, see, it will run it as that. Expected type found the result. Can I just from parsing? I just Do it twice. Actually, I'm starting to believe map error. Parse non-positive from parseInt. Yes. Damn. We are getting. Well, am I getting there? It just makes perfect sense. I mean, it doesn't, but I'm starting to believe in what Rust wants me to teach. What Rust wants to teach me. Generics I have read beforehand. I'm gonna say that it's very wild that the order in which this goes. So generics. No, actually, it is in the correct order. Great. Never mind me, I'm stupid. 14, 1. Generics. We have 2 exercises. This is going to be fast. So vec_t is generic over the type t. In most cases, the compiler is able to infer t. For example, after pushing a value to a concrete type to the vector, for example, after pushing a value with a concrete type to the vector. But this exercise, the compiler needs some help to do a type annotation. Fix the compiler error by annotating the type of the vector vec_t. Choose t as some integer type that can be created from u8 and i8. Let mat t wait. What was this? Consider giving it number as an explicit type, where the type of t is specified vec_t. Numbers. Yeah, whatever. U sides, sure. I32. This is not even an exercise about genetics, honestly. Sol gen 1. Don't change time below. Yeah, disappointing. This powerful wrapper provides the ability to store a positive integer value. Rewrite it using a generic so that imports wrapping any type. So value u32 implements function u32 return and yeah, want to be a string. This u32 goes straight up to t, I believe. Actually, forgot about this part. That one should be fixed. I could swear that this is how you do it. Implement t point t. So implement t wrapper t. Easy as that. I don't believe there's another way to make this, right? There's basically no way to do it different. Of course it isn't. Well, the generic one was absolutely dog shit. Like the first one in particular. There we go. Now we gain something funnier. Traits. Trait 1. It's the good shit. I've read also the trait explanation, so that's good. But the traits are in the same chapter. Good. So it's 16 going to be automation tapes, no, lifetimes, which are on traits, 17 tests. It goes in order. So from this point going forward, I'm going to read before taking the exercise. It just makes more sense and feels a little bit better. Feels a lot better. The trait append bar has only one function, which appends bar to any object. Implementing this trait. Trait append bar function append bar self. Implement append bar for string. Implement append bar for the type string. Which would mean something of the lines of self.append. No, it's the type of this. It's a string, right? String. Wait, it's an actual string. Strings had a method to append. Don't remember which one was it. String append. String. String. Module string. Append. Wait, I can also plus it. So plus bar. So it's a capital bar. There we go. This expression creates a reference, which means the reference by the compiler. Change this to bar. Like without or the curly. Also you can. Let's go. Solve trait 1. Trait append bar has only one function, which appends bar to any object. Implementing this trait. Self plus bar. Perfect. Trait 2. Append bar defines so self implement the trait append bar from a vector of strings. Append bar should push the string bar into the vector. Easy as that. Wait a second. Oh, I can implement it for the string itself. That's cool. Self.push capital bar. This much char from str. Oh, okay. I can absolutely just do it in a stupid way. Char found expected char. Isn't this a char? Yes, it is. Mismatch string found mismatch type found object. I don't return a string, right? Actually, I don't think I return. He does return self. Self. Well, masher is going to be immutable. Okay, vex string, my bad. So push returns something. This means push returns something. Fun. Imp pub fun. Yeah, the signature means that I have to let A equals that. A. But am I not getting a back string? Because well, I'm getting a back, right? Isn't it enough to say it like it's a back or whatever? Okay, so vex string, it's happening. But, however, let's try the vex string. If I say back string isn't going to get crazy on me. Feels like he will just get gang on me. Okay, so push does do some bullshit like that. Let's say like that. Let's say copy something. Copy back. Let's just copy the back. There you go, back to back. So let mute TMP is going to be my self to back. There we go. Now I can push on my TMP whatever the fuck I want, which is going to be the bar string, and then return my TMP. There we go. Sol What's this? Stuff trait. Yes, it's true. Son of a bitch. Could have sworn that I tried this. Like I could have sworn that I tried that. Must have missed something. Whatever. Still counts. Don't care. So we're talking about 60, 30 more to go. With only 10 days left. Speedrun time. Trait licensed add. The default implementation for licensing info, so that implementation like the two structs below can share the default behavior without repeating the function. The default license information should be the string default license. Easy as that. Default license to string. I'm not even going to bother checking. Do I need sol? At this point, let's just check. Very well. Number 4, trait licensed. Function license info self string. Same thing we got beforehand. Struct license fix the compiler error by only changing the signature of this function. Function compare software. Some software, other software. This is my expectation. Okay. Otherwise, this shall be a generic. So type T, type K. This is T, this is K. That implements licensed. See? That's why you read the docs. Because basically, you can tell what trait I want to be implemented. Since we have the same trait, the compiler can guarantee that this function exists. This function returns a string, so everything works out nice. Now, I would be shocked if the solution would be any different, which it is. Yeah, mine is a little bit of an overkill. I forgot that you can just say that it implements licensed. This is the long hand, and again, I don't understand why Rust can be so. Well, I don't understand why the Rust can be so, what you say, so explicit and implicit at the same time, because it's very explicit to say all of that stuff. But you can also just implement licensed, which is going to cancel the idea that there's an generic under the hood. And I have to understand, I have to know that this happens. And the more of this stuff you stuff your language, I believe that every time that you're not programming every 5 seconds with Rust, you're going to be confused and not remember all of these small nuggets that the language has and that you don't remember because, of course, you don't remember everything unless you, again, work every day with Rust. I mean, shouldn't be a problem if you use it every time. But again, it's way too many. I think at some point you're gonna get wrecked and skill issued on yourself. I have to definitely try a project. Because so now it feels a pleasure, but it's never a pleasure when you actually do something new. It always feels easier. Actually, if you can excuse me a minute, I'm gonna go and say hi to my mom, and I'm gonna be back. Nie mam wyszedł nawet. Wait. Say, bots. Well, that was a nice little break. Couple of minutes at 1 hour mark, 50 minutes mark. So shall we say, what's the big deal here? So some trait and another trait, both gets you through. Some both implement that trait, fix the compile error by only changing the signature of this function. I thought that the signature it is without the body. It isn't. Anyway, items should implement Dude, what? Does this count as a word because everything is a special character? Well, so we are implementing some trait, but it won't work because you have to implement both. Now this is the time where I believe it will be t dot some trait plus other trait. And we pass it. There we go. I don't know how I feel about. I mean, this is cool. I don't know. I don't feel I would be using this very soon. Simply because I don't see myself stuffing a lot of stuff in trades for now. Maybe because I don't still have a great idea of structure in general as of programming. Probably should probably do something programs that are bigger enough that I can struggle. I can get to a point where I struggle a lot and I have to organize my code base better, or even works in organized code bases. But if I don't organize it myself, I'll never understand why stuff happened. Like it's always superficial if you're not the one that is thinking about why this sucks and why this needs to be better. Yeah, so implement trait, other trait. Fantastic. So, trait 6, action. Oh no, traits are done. Quizzes. Quiz 3. There we go. This quiz test generics and traits. An imaginary magical school. By the way, I am actually listening to all of the Harry Potter books. They're ass, but they keep me company. Actually, that's not true. Besides the first and the second one, I'm hating everything because the third movie is amazing, but the first book is the third book is balls because everything that there is imaginary sports. You see a lot of Quidditch and nothing else, and I'm struggling to get on with it, but I want to finish because I usually don't quit most books or series in general. It's very rare, and I remember only quitting like one book when I was younger. I used to read a lot of fantasies. Now I transitioned to comic books because I don't know, it's just easier, I guess. There's a lot of reading in my job as it is, and you don't want on the night to also start again into the reading. I have from my girlfriend the Kindle. Perhaps I should. You know what? I have to read off. So first of this comic book, just from my friend. It's the Cthulhu stories. Cthulhu, what's his name? The dude. There's one dude that wrote the Cthulhu. There we go. H.P. Lovecraft. So that goes on the bed. And I have a news agent, so my mom has these magazine editions of books and stuff. I always grab something up, and the one, because the first numbers cost like $2. The one is Sherlock Holmes Baskerville, in Italian, Baskerville Mastiff, I guess it's in English. Should be a Mastiff. Goes on the bed. Hopefully tonight I'm gonna take a look. I don't count on it, but hopefully. Yeah, that was a big detour. An imaginary magic school has a new report card generation system written in Rust. Lord. Currently, the system only supports creating report cards where the student's grade represent numerically 1 to 5.5. However, the school also issue alphabetical grades and needs to be able to print both types of report cards. Make the necessary change in the struct report card and implement block alphabetical report addition to numerical ones. Now, I want to say, I like that this gets the idea very much in Headspace. That the first one that actually convinced me about how cool generics are is when you make a game. There's going to be a lot of copy pasting, and you can change the situation very much. The bigger one, like, is going to be the damage system, where you have to check that everyone is getting collided. And of course, you want to be a trait, because if you're going to make a damage system and everyone has to be collided, or even not a damage system, might actually even be a stopping system, it is a good idea to have two different types that when collided, it will do damage, because the player takes damage from the mobs. the player doesn't do damage to the mobs, but the projectors of the players do damage for the mobs. That was the greatest way I felt into using traits, generics. To do, adjust the struct as described above. Report card grade F32, student name string, and student age U8. Well, this will implement T, which would be T. The implement block should have generic T by type T, and we should be T does implement display. Standard format. It will kill my. It won't. Nice. For report card. Won't. Son of a bitch. Alright. This trick shot should do it. Perhaps. Let's say it doesn't implement the bug. Son of a bitch. There was a way to say implement this stuff. There was a way like to star this format debug or something. God damn it. Consider restricting type parameter T. There was a way to restrict it to some type. Can I get a generic data of two of them? Let's get a hint. Yeah, a hint is good. To find out the best solution to the challenge, you need to recall your knowledge of trait-specific trait-bound syntax. Here's how to specify a trait for bound for next implementation. You may need this. Use standard formatted display and implement T not of trait display, not of trait display. Print is not of trait display. Oops. Yeah, I know what it wants from me, but I don't understand how to give to them. Implement for this boy. So that's how it is, right? Okay. Getting a little bit stunk over here. So this won't work because I need to display stuff. Give a generic display. What's it called? Rust. Son of a bitch, this. Display for where? I'm gonna say something that Rustaceans won't like. It feels like C# with the with the where bullshit. Set mutable formatter. Nope, 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 nope. Son of a bitch. How about I'm gonna give you like this. See? Hehe. Okay. Hehe. String. Not sure. The print does not have a trait of display. Fuck you. Now, I don't like this shit. Right? Display. Fuck you. Display. Still works. Unused import. My bad. Fuck off. Amazing. Yeah, now I remember it. I actually done this before, so I don't know why suddenly it's hard, because I've done this literally the exercise before that. So it's a grade T, of course. So display card, oh, of course. Fabulous. Lifetimes. Oh shit, I did not finish to read lifetimes. The fun is over. The fun has been completely destroyed. No, actually, I finished the lifetimes. No, I didn't. So the idea would be in Rust, the rules, which are basically, it's basically an auto free of some kind. So in Rust, everything that goes out of scope gets freed. That's why this kind of code won't work, because X gets freed, but R is supposed to have a reference to X, and it gets burned down. Now, he also makes an example along the way like this. This example I do not quite understand, because the idea would be that I don't know which one to take the reference of, and that causes problems to the program, right? But again, not right. It doesn't feel to me like it's a big problem. Because what function that returns the longer of the two strings? This function will take two string slices and return a single string slice. And we implement the longest function that calls this string. Should print the longest string is abcd. Function main, so abcd xyz and give me the longest. I want the function to take string slices, which I prefer rather than strings, because we want the longest string function to take ownership of its parameters. Refer to blah blah blah. If you want to try the longest function listing, it won't compile. Because, so let's read the error a little bit. Missing lifetime specifier. Function longest expected named lifetime specifier. Help. This function returns the type contains a borrowed value, but the signature does not say whether it is borrowed from X or Y. Help. Consider lifetime. So you add all of the signatures, or in the signature of the lifetime. The subtext reveals that the return type needs to be a generic lifetime parameter, because Rust can't tell whether the reference being returned refers to X or Y. This is what I don't know. Is it because when the function returns, you have to free, so he doesn't know what to free? Because the free gets introduced in the compiling step. I feel like the free gets introduced in the compiling step. Then that means that you can't at runtime decide which one to return, which means you don't know it will segfault or dangling reference, or pick one. I know there's three. I know their name. I don't know. I don't always remember what they do. So let's try and ask ChatGPT about this. Why doesn't Rust know? Why does Rust needs to know the lifetime? Is it because the borrow checker works at compile time and it doesn't know what to free? That would be my assumption, because if it works at runtime, you can free on whatever it is. Yes, Rust needs to know the lifetime reference because that's how the borrow checker works. Borrow checker ensures the memory safety of compile time memory safety. That prevents dangling reference, which occur when reference a point of memory that has been freed. For example, if X, yeah, dangling reference, dude, so good. I'm great. For example, if X and Y in your longest function goes out of scope while return the reference is in use, this will lead to behavior in language like C or C++. So yes, the borrow checker works. That's why, by the way, Rust compiles in 5 hours. The borrow checker throws the stuff. The borrow checker adds the freeze at comp time. Yes. Does the borrow checker add the free at compile? But dude, but compile time. So I'm gonna run under this assumption. If sometimes this assumption gets challenged, I can deal with that. I'm gonna take a look at that. Actually, no, either, because if block returns the reference x as both returns f of y. When we're defining this function, we don't know the complete value that will be passed into this function. So we don't know whether if case or else gets executed. We don't know the complete lifetime of the reference will be passed in, so we can't look up the scope as we did in listing 1017 and 1018 to determine whether the reference will return will always be valid. The bot checker can determine this either, because it doesn't allow how the lifetime of x and y relate to the lifetime of the return. Fix that we add a generic lifetime parameter that defines the relation between the reference to bot checker and perform its analysis. Okay, lifetime okay. So what is the difference of this? This will take the idea is this will free the shortest lifetime. So this will free the shortest what you say? The shortest scope. Again, speaking always talking to lifetime implies the concept of time, which is not what here is happening. It's more of a scope, which has time, but you're thinking more about how long it lives in terms of execution, in terms of extractions. So I feel better thinking it about as a scope rather than a lifetime. The whole word of lifetime doesn't work. So there's a lifetime annotation in this function. Am I, by the way, still live, still listening? Good. Great. I generally hope that my voice doesn't sound half a second before. So this lifetime annotation is function signature. We need to declare the unique lifetime parameter inside the angle brackets. So this compiles. There's now Rust that the lifetime, the function takes two parameters, both of which are string slices that live at least as long as lifetimes a. Okay, so you impose that this lives as long as the function, but why won't you assume that this is how it works? The function signature also tells us that the slice returned from the function will have at least as long as life as a. In practice, it means that the lifetime of a reference returned by the longest function is the same as the smallest of the lifetimes of the value referenced function arguments. These relationships are what we want to use when analyzing Rust code. So I didn't finish this one. Okay, time to finish. Remember, when we specify the lifetime parameter in this function signature, we are not changing the lifetime of any value passed in or returned. Rather, we specify that the borrow checker shouldn't reject any value that don't adhere to these constraints. Note that the longest function doesn't need to know exactly how long x and y will live, only that some scope can be suited for a that will certify the signature. So this is basically a smoothing of the rules. You're just saying, hey, chill the fuck up. Don't worry, there's nothing, not a problem. I don't see yet the problem of not knowing which one will return, because you still have the parameters in the signatures. So I would assume that that parameter live enough time. Is it really a problem that it's still alive in this scope? But he talked about dangling reference, which means the problem isn't that stuff won't get clean. The problem is that I know if the stuff that I return is still alive somehow. But this will guarantee that it lives to the whole function. That's how I'm envisioning it so far. When I'm taking a lifetime in function, the annotation goes into the function signature, not in the function body. That annotation become part of the contract of the function, much like the types in signatures. Having functions signatures containing the lifetime context means the analysis of task compiler can be simpler. If there's a problem with with the way a function is annotated or the way it is called, the compiler errors can point to the part of our codebase and the constraints more precisely. If instead the Rust compiler made more inferences about what we intend the relationship of the lifetime to be, the compiler might only be able to point to a use of our code many steps away from the cause of the problem. When we pass concrete reference to longest, the concrete lifetime that is substituted for A is the part of the scope of X that overlaps with the part of the scope of Y. In other words, the generic lifetime A will get the concrete lifetime that is equal to the smaller of lifetime of X and Y. Because we noted that the return references with the same lifetime parameter A, the return will also be valid for the length of the smallest of the lifetime of X and Y. Okay, which would be X. This stuff, okay, this is hard. Lifetimes are hard to understand. I feel like they won't be hard to use, but it's hard to wrap my head around the problem here. I don't understand the problem that they solve. I don't know why that's the problem. Yeah, I can't wrap my head around. Probably exercises will help. Let's look at how lifetime annotation restrict the longest function by passing in references that have different concrete lifetimes. So let's string 1, let's string 2, result, string 1 plus string 2. In this example, string 1 is valid until the end of outer scope. String 2 is valid until the end of the inner scope, and the result reference something that is valid until the end of inner scope. And in this corner, you see that the borrow checker approves. It will compile the longest string is long. Okay, because the lifetime is going to assume the lifetime of string 2. Now this is better, but why can't it assume that it's always the shortest? Will that cause some kind of problems that I don't get? Next, let's take an example that shows the lifetime of the reference in a result must be smaller lifetime of the two arguments. We move the declared of the result variable outside the inner scope, but leave the assignment value result variable inside the scope of the string 2. Then we move println and use a result outside the inner scope, and the inner scope has ended. The code listing will not compile. Of course not, because since we used this one, actually not because we used this one, but because we are outside the scope, we cannot retrieve this value if this is the value that it gets returned. Binding string 2 related here, borrowed value doesn't not live long enough. Yeah, because it's borrowed. Fair. So it is used here. The errors show that the result to be valid for the println statement string 2 would need to be valid until the end of the outer scope. Rust notice because we annotated the lifetime of the function parameter and the return value using the same lifetime as A. Okay, so substantially A means shortest lifetime. Okay. As humans, we can look at this code to see that string 1 is longer than string 2, and therefore the result will contain a reference to string 1. Because string 1 has not gone out of scope yet, a reference of string 1 will still be valid for println statement. However, the compiler can see that a reference is valid in this case. We've told us that the lifetime of a reference returned by the longest function is the same as the smallest of the lifetime of the reference passed in. Therefore, the borrow checker disallows the code in listing 1033 as possible valid and invalid reference. Try designing more experiments that validate the values of lifetimes of the reference passed into the longest function, how the return value is used. Make hypotheses about whether or not your experiment will pass the borrow checker before you compile, then check to see if you're right. Makes me feel like Rust doesn't allow you to write every program possible. Makes me feel like there's some programs that either cannot be written or is going to be so hard that it might as well be C++. Speaking in terms of lifetime, the way in which you need to specify lifetime parameter depends on what you want, on what your function is doing. For example, if we change the implementation of longest function to always return the first parameter rather than the longest strings, we won't need a specified lifetime of y parameter. The following code will compile. Um, Basically, since I know that y doesn't get used, I don't care. It's out of read. This is a pathetic use of lifetimes. You specified a lifetime parameter a for the parameter x and then return the type, but not the parameter y, because the lifetime of y does not have any relationship with the lifetime of x or the return value. When returning a reference from a function, the lifetime parameter for the return type needs to match the lifetime parameter for one of the return parameters. If the reference return does not refer to one of the parameters, it must refer to value created within the functions. However, this will be a dangling reference because the value will go out of scope at the end of the function. Consider this attempt implementation for the longest function. A, x, y, a. Here, even though we specify a lifetime parameter a for the return type, this implementation will fail to compile because the return type value lifetime is not related to the lifetime of the parameters at all. Okay, because we are not borrowing. The problem is that the result goes out of scope and gets cleaned up at the end of the longest function. We are also trying to return a reference to result from the function. There is no way we can specify a lifetime parameter that would change the dangling reference, and Rust won't let us create a dangling reference. In this case, the best fix to be able to return its own data type rather than a reference, so calling function is then responsible for cleaning up the value. Ultimate lifetime 6 is about correcting the lifetime values. It's so boring. And returns value function. Once they're ultimately, lifetime syntax is about connecting the lifetime of various parameters and return value function. Once they're connected, Rust has enough information to allow memory safe operation and disallow operations that will create dangling pointers or otherwise violate memory safety. Lifetime annotation in struct definition. So far, the structs we've been defined are all hold on types. We can define structs to hold references, but in that case, we will need to add a lifetime annotation on every reference in the struct definition. What? First sentence, novel, split, next, unwrap. So for constructs we then hold on types. We can define structs to hold on references. Oh, pointers. Okay. So we can point them. Pointers. Okay, so this struct has the single field part that holds a string slice, which is a reference. As generic data types, we declare the name of the generic lifetime parameter inside angled brackets after the name of the struct, so we can use the lifetime parameters in the body of the function definition. This annotation means an instance of import except can't outlive the referent it holds part field. Okay, fair. The main function here creates an instance of import except struct that holds a reference to the first import string owned by the variable novel. The data in novel exists before the import excerpt instance is created. In addition, novel doesn't go to scope until the import excerpt goes out of scope, so the reference import excerpt instance is valid. Lifetime elision. I don't know what elision means. Omission. Okay. Very, what will you say? The term that comes to mind is suave, but it's not suave. Very elegant term. You learned that every reference has a lifetime, and you need to specify lifetime parameters for function or struct that used references. Oh, that's why. Have I not known? Okay, so that's reference. Okay, now the dangling stuff gets better. Yeah, can always do this. Or it doesn't work. Nice. You learned that every reference has a lifetime and you need to specify lifetime parameters for function or stack that use reference. However, the function listing 49 shows again a listing 1025 that compiles without lifetime annotations. The reason this function compiles without lifetime annotation is historical. In early versions of Rust, this code wouldn't have compiled because every reference needs to explicit lifetime. At that time, the function signature would have been like this. Now that's balls. After writing a lot of Rust code, the Rust team found that the Rust programmers were entering the same lifetime annotation over and over in particular situation. These situations were predictable and followed a few deterministic patterns. The developer programmed these patterns into compiler code so the borrow checker could infer the lifetime in this situation and wouldn't need explicit annotations. And here we go, more magic. See, Rust has a lot of magic. Same as all of the dynamic higher language, especially Ruby. By the way, Ruby has a lot of black magic and you don't ever know what's going on. In this case, I guess you do, but this is another thing again. It's another watching thing that you need to remember. Oh, you know, there's actually some lifetime under the hood, which will take your lifetime from beforehand. I don't know, I don't like black magic languages, but I'm enjoying writing Rust. I have to use it. I really need to use it. Sips water. The developer programmed these patterns. The piece of Rust history is relevant because it's possible that more deterministic patterns will emerge and be added to the compile. In the future, even fewer lifetime annotation might be required. The patterns programmed into Rust analysis of references are called the lifetime elision rules. These aren't rules programmers follow. They're set particular cases that the compiler will consider, and if your code fits these cases, you don't need to write lifetime explicitly. The elision rules don't provide full inference. If there's still ambiguity as to what lifetime the reference have after Rust applies the rules, the compiler won't guess that the lifetime of the remaining reference should be. Instead of guessing, the compiler will give you an error that you can resolve by adding the lifetime annotations. Lifetime on a function or method parameters are called input lifetimes, and lifetimes of return values are called output lifetimes. The compiler uses 3 rules to figure out lifetimes of the reference where there aren't explicit annotation. The first rule applies to input lifetimes, and the second and third rules applies to output lifetimes. If the compiler gets to end on the 3 rules and there are still references for which can't figure out lifetimes, the compiler will stop with an error. This rule applies to function definitions as well as implement blocks. Implements. The first rule is that the compiler assigns a lifetime parameter to each parameter that's a reference. In other words, a function with one parameter gets one lifetime parameter. A function with 2 parameters gets 2 separate lifetime parameters. Okay. The second rule is that if there is exactly one input lifetime parameter, the lifetime is assigned to all output lifetime parameters. Fair. Third rule is that if there are multiple lifetime parameters, but one of them is self or mute self, because this is a method, the lifetime of self is assigned to all output lifetimes. Fair. The third rule makes method much nicer to read and write because fewer symbols are necessary. Let's pretend that we're the compiler. We'll apply these rules to figure out the lifetimes to the reference in the signature of first word. The signature starts with writer associated. Yeah, it's going to be A. I'm going to guess that it's all A's. When the compiler applies the first rule, specifies that each parameter gets its own lifetime. We call it A as per usual. Alright. The second rule applies, which means it's going to be AA. Now let's reference this function to have a lifetime, and the compiler can continue its analysis without it. Let's look at another example, the longest. A function had no lifetimes. apply the first rule. Each parameter gets its own lifetime. The lifetime, we have two parameters instead of one. So we have two lifetimes. AB, AB. Now we see the second rule doesn't apply because there is no more. There is more than one input lifetime. The third rule doesn't apply either because longest is a function rather than a method. So none of the parameters are self. After working through all three rules, we still haven't figured out what the return type lifetime is. This is why we got an error trying to compile the code in listing 1020. The compiler worked through the lifetime elision rules but still couldn't figure out all of the lifetimes of the reference in the signature. Because the third rule only applies in method signature, we'll look at the lifetime in that context next to see why the third rule means we don't have annotated lifetimes in signature very often. Third rule was alright, so one of them is self-immute, so this doesn't apply. My god, come on man. Come on, we can do it. When we implement methods on a struct with lifetime, we use the same syntax as that of generic type parameter shown in 10.11. When we declare and use the lifetime parameter depend on whenever they're related to the struct field or the method parameter and return values. Lifetime names for structure fields always need to be declared after the implement keyword and then used after the struct's name because of lifetimes are part of the struct's type. In the method signature inside the implements block, reference might be tied to the lifetime of references in the struct's fields, or they might be independent. In addition, the lifetime elision rules often make it so that lifetimes annotation are necessary in the method signatures. Let's look at some example using struct named that we define in list 1024. First, we'll use a method named level, whose only parameter is a reference to self, and whose return is I32, which is not a reference to anything. So this compares. The lifetime parameter declared after implements and it's used after the type are required, but we're not required to take the lifetime of the reference self because the first religion rule. An example where the third religion rules apply. Yeah, because this is the lifetime of self. There are two input lifetimes. So Rust applies the first rule edition rules and give both them self and announcement their own lifetimes, but because one of the parameters is self, the return type gets the lifetime of self, and all lifetimes have been accounted for. One special lifetime we need to discuss is static, which denotes that the affected reference can live for the entire duration of the program. All string literal have the static lifetime, which we can annotate as follows. Let static string. Oh. The text of the string is stored directly in the program binary, which is always available. Therefore, the lifetime of all string is static. It might suggest to use static lifetime in error message, but before specifying static as a lifetime for a reference, think about whether the reference you have actually lives the entire life of the program or not, whether you want it to. Most of the time, an error message suggests a static refer lifetime from attempting to create a dangling reference or a mismatch of the variable lifetime. In such cases, the solution is to fix this problem, not specifying static lifetime. Fair. Generic type parameters, trade bounds, and lifetime. Let's briefly look at the syntax specifying generic type parameters, trade bounds, and lifetime all in one function. Longest announcement, AT. This is a Okay, so lifetime, trait, teaser display, and here we go. This is ugly as it can get. I have to share it. I'm sharing this with my friends. This is the longest function from listing that returns the longest of two string, but now it has an extra parameter n, generic type t, which can be filled in by any type that implements display trait as specified by the where clause. This extra parameter will be printed using brackets, which is why the display trait bound is necessary. Because lifetimes are a type of generic, the declaration of the lifetime parameter quote A and the generic type parameter T go in the same list inside the angle bracket after function A. We are so in. Reading out loud is harder than expected. Let me get on a message and then we go. Let's follow my friend back, by the way. She's an illustrator, so I hope she gets live so I can see from time to time how stuff goes. Alright then. This is good enough. This was enough reading. It's time to do some shit. The quiz test is done. It's a lifetime one from the exercises. This compiler needs to know how to check when supplied references are bytes so that it can let the programmer know if it's at the risk of going out of scope before it's used. Remember, the references are borrowed and do not own their own data. What if the owner goes out of scope? So this is the case that we've seen there. A, and so forth and so on. This is the ugliest code that I have ever seen. Not even bothering to checking this. Lifetime 2. Don't change this. Fix the compiler error. Yeah, what's the deal? Declared here, string does not live long enough. Borrowed value does not live long enough. My guess would be to do this. Let's see what his guess is. Sol life 2. So showing you can move the string outside. Amazing. So 2, you can move the print statement into the inner block. Feels like cheating a little bit. Feels like it. Items are also needed when structs hold references. Fix the compiler error about the struct. Yeah. It was way easier to just work it out. Oh, my bad. The final concept is easier, but again, same criticism that I have as of every stuff that I don't quite understand is because it's always easy, but when you get into a edge case and you don't know specifically what this does, you simply do not get to understand what's going on. You simply don't get to understand what's going on. Now you're frustrated because all of this stuff that should be quite simple, it isn't, because now the edge case don't now you have to dig deep or suffer. There's a lot of reading going on now, but I know how it ends if I don't read. I'm not telling it. All right. So in 1972, let's say the humble programmer adds Gervo Dijkstra. Oh, fuck off. Not Dijkstra again. So the programming testing can be a very effective way to show the presence of bugs, but it's hopeless inadequate for showing their absence. That doesn't mean we shouldn't try to test as much as we can. About that. Is testing not a good enough way of showing if your code has bugs or not? I never saw testing as a way to get out the bugs. I always saw the testing as a way to make sure that bug doesn't happen ever again. Like in my first job, I used to we used to write a unit test every time that a bug comes in, meaning there's an exception or whatever it is. You're going to find the problem, fix it, write a test. So the next time when someone Ciao ma, buon lavoro. Now the next time someone ever gets at the same point or modifies the code in the same direction, or modifies the code in another part, it won't interfere with what you written before. So that's my personal expectance of the test. The test should say, this is what the code is supposed to do. So there, what the fuck do you say? It's it's one way to write documentation, which is active because the documentation has to compile, which means it has to work. And it gives me a little bit more consistency because either I'm doing some change that I have to wipe out the test, or the change is small, so I have to make sure that what I want to happen. For edge cases, probably what Prime is doing is better. He's doing that stuff of simulation testing, which I wonder how hard it is to do because it sounds delightful. Probably overkill for most people, but for business important systems, it could be actually great. Correctness in our program is the extent to which our code does what we intended to do. Rust is designed with a high degree of concern about the correctness of program, but correctness is complex and not easy to prove. Rust type system shoulders a huge part of this burden, but the system cannot catch everything. As such, Rust includes support for writing automated software tests. Say we write a function add2 that adds whatever number it passes to it. This function signature accepts an integer as a parameter and returns an integer as a result. When we implement the compiled function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we aren't passing a string value or invite a reference to this function. But Rust can't check to this function with the precisely what intended, which is return the parameter plus 2 rather than say the parameter plus 10 or the parameter minus 50. That's where the test comes in. Yeah, sure. How to write test? I'm feeling lazy. Also, my voice hurts. Guess tonight was a little bit cold. I should wipe out my huge pajama for tomorrow. I am feeling tired, and I have to drive 1 hour from my job. For my job, I know that my public is mostly American, so 1 hour is, well, actually it's going to be closer to 45 minutes. Is child's play, but dude, I'm not getting paid to drive. I'm getting paid to get to my job. And my office being there is annoying. Once a week is fine, but still is annoying. So, test how to write test. Test a Rust function that verify that non-test code is functioning in the expected manner. The bodies of test function typically perform these three actions. Okay, gotta set up my posture and get over with. Let's suffer for 15 minutes the good way. Set up any needed data or state, run the code you want to test, assert the results are what you expected. Let's look at a feature Rust provides for writing tests that this action takes this action, which include the test attribute, a few macros, and the should panic attribute. The anatomy of a test function. At simplest, a test in Rust is a function that's annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the derive attribute we used with structs in chapter 5. Change a function into a test function, add hash test on the line before function. When you run your test with the cargo test command, Rust binds a test runner binary that runs the annotated function and reports whether or not each test function passes or fails. When we make a new library project with cargo, a test module with a test function in it is automatically generated for us. This module gives you a template for writing your tests, so you don't have to look up the exact structure and syntax every time you start a new project. You can add as many additional test functions and as many test modules as you want. We explore some aspect of how tests work by experimenting with the template test before we actually test any code. Then we write some real world tests that call some code that we've written and asserted its behavior is correct. Let's create a new library project called adder that will add two numbers. So new adder lib. The contents of lib file in your adder library should look like this. So the adder and the test. Wait. Do you keep the tests with the code? That's bizarre. That's very bizarre. For now, let's focus solely on it works functions. Note that the test annotation, this attribute indicate, oh no wait, this is a module, so I could module this out and then you're going to import in the test files. This will indicate that the test is a function, so the test runner knows to treat this as function as a test. We might also have a non-test function in the test module to help set up common scenario or perform common operation. So we always need to indicate which function are tests. The example function body uses the assert equal macro to assert that, dude, I want to know what a macro is. I want to know about macros because this feels like magic and I keep getting triggered by this. It's going to be a macro, right? I'm dropping them right now. Okay, that's macros. At 21, we are 31 exercise. Well, I'm not finishing this up until the 1st of January. So sad. My completionist My completionist core is hurting right now. In my soul, I want it to be completed. I want it to be completed the way I want it. The example function body use the assert macro, which contains the result of adding 2 plus 2 equals 4. This assertion serves as an example of the format for a typical test. Let's run and see the test passes. Cargo test running. Okay, test results. Good. Cargo compiled and run the test. We see the line running one test. The next line shows the name of the generated functions. Test work. And the result of running test is okay. The overall summary test results okay means that all tests passed, and the portion that reads 1 passed, failed, 0 failed, total number of tests passed or failed. It's possible to mark a test as ignored, so it doesn't run in a particular instance. We'll cover it in the ignoring some test unless specifically requested. The section later in the chapter. Because we haven't done that here, the summary shows 0 ignored. The zero measure statistic is for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in nightly Rust. See documentation about benchmark tests to learn more. I'm not benchmarking anything as for now. I wish to do some benchmarks, which makes me remember this amazing game, which is the 1 billion lines challenge. So 1 billion line challenge, which would 100% going to be a good way to get into the measurement of some performance, which I never ever get to do it. Because writing for the web is the bullshit stuff of writing for the web. You don't ever get into interesting performance bottlenecks. The performance bottlenecks are always going to be someone made something stupid, or we just need to, I don't know, cache something, split the database. There's way more, easy is not the correct way. There's way more simple solutions than just go and grind the code until it works. And I never get to the idea to actually squeeze out performance, which sounds fun. I feel like I want to be a game developer, but I don't really game. So I don't want to go into the job that I don't care. I wish to do the job that I don't care, that pays me a lot, which is web dev. So, which is not paying me a lot now. Hope it keep paying me more and more. We can pass arguments to the cargo test. Command to run only test whose name matches a string. This is called filtering. And we'll cover that is the running a subset of tests by name. Nice. Sweet. I love it. It would be even better if I can run tests by module. So I could run or by crate, I guess. Anyway, the scope of a folder. You haven't filtered the test being run, so the end of the result shows 0 filtered out. Next part of the test, output starting a doc tester adder is the result of any documentation test. We don't have any documentation test yet, but ask compile any code examples that appear in our API documents. This feature keeps stack your doc and your code in sync. Now, this is everything. This, I don't know why I point. This is everything. This is what I think is very cool. Because I added some docs. Again, one of the things that I'm bad at, I don't usually document my code and don't usually think that tomorrow will be needed to be read. So that's another way in which I could improve in the next project. So see, reading this is actually very useful in general, not only for Rust. Plus, now I finally can understand when people bitch about Rust online. I follow a lot of the Primagen. I don't follow Theo because I don't really like him. Theo is a yapper, but a different type of yapper. He's not a yapper of I done this is my idea. He's a yapper of the number one promoter of JavaScript, or I guess TypeScript, but come on. Potato potato. We'll discuss how to write documentation in documentation comments as tests. Section of chapter 14. Can't wait. For now, we ignore doc tests. Let's start to customize the test to our needs. First, change the name of it works function to a different name, such as exploration. Then run cargo test again. The output shows exploration instead of it works. Good. Now we'll add another test. But this time we'll make a test that fails. Test fails when something is in the test function panics. Each test is run in a new thread. And the main thread sees that the test thread has died. The test is marked as failed. In chapter 9 we talk about how the simplest way to panic is to call panic macro. Enter the test, a new function named another, so your lib rust file looks like this. This panics, one failed. Spectacular. Instead of OK, the lines test shows failed. Two next section appear between the individual. Yeah, so it's going to be also there you go. So this is the stack trace. In this case, we will get the details that another failed because it panicked at make this test fail on line 17. Next section lists just the names of the qualifying tests, which is useful. But there are a lot of tests and lots of details failing test output. We can use the test name of failing test to run the test to more easily debug. And we'll talk about ways to run tests in the controlling how tests are run section. The summary line displayed at the end overall our test result is failed, blah blah blah. We had one test pass and one failed. Checking the result with the assert macro. The assert macro provided by the standard library is useful when you want to ensure that some condition test value is true. We give assert macro an argument that evaluates to a boolean. If the boolean is true, nothing happens and the test passes the value. If the value is false, the assert macro calls panic. Using the assert macro helps us check that our code is functioning the same way. In chapter 5, we use a rectangle start that can hold method that are placed here in 11.5. Let's put this code so then write some tests for using it as a macro. So struct a rectangle u32 u32 implements a rectangle self width, other width, and self height, other height. The can hold method returns a boolean. Yeah, I know what this means. So larger, smaller. Note that they use super lines inside the test module. The test module is a regular module that follow the usual visibility rules covered in chapter 7. Because the test module is inner module, we need to bring the code under test and outer module in the outer scope of the inner module. We use the globe here, so anything we define in the module is available to this test. So derive the bug and get everything inside the module. Okay. Oh, so super, like in Java, you take the outer scope and bring everything in. Okay, so our test pass. Because the correct result of can hold function in this case is false, we need to negate that result before we pass to assert macro. As a result, our test can hold. Now, isn't smaller can hold large? Yeah. So test pass. Now let's see what happens when we introduce a bug in our code. We change the implementation can hold method by replacing the greater than with a less than and compare the width. This got the bug because the large width is 8 and the small width is 5. Yeah. Testing equality with assert equals and assert not equals. Okay. Adding custom message failures. Okay, so if you pass a second pass a second value, it would be second. If you pass the second argument, it will print it out. Amazing. Checking for panics. Should panic, right? Use result E. Okay, I can use my optionals instead of my I can use my optionals instead of my panicking. Here's fine. Controlling how tests are run. Running tests in parallel or consecutively. If you want to run tests in parallel, you want more fine-grained control over the number of threads used, you can use set test threads. I can change if I want the output. Okay, so by default, prints won't get shown, show output. Okay, same as go. Make a subset of tests by name. Add 2, add. So add 2, add 1, 100. And we see all three. But if I say cargo test 100, it shows only 100. Filtering multiple test, cargo test add. This would make a pattern match. So, well, pattern match. This would make a. This will grep. Ignoring some testing is specifically requested. Dude, I'm getting so lightheaded. Why is reading aloud so hard? Ignoring some tests unless specifically requested. Okay, so you can ignore. Good. This is nice to, put a test that it's not ready yet, so you can finish whatever you're programming and then test it from time to time, not every time. Oh fuck, my battery is dying. Tablet, goddammit. Test organization, the test module, GFG test. Oh, I want to know about this. On this module, Rust tests compile and run the test code only when you want to run cargo test, not when you run cargo build. This saves time, compile time, and you want to build a reliable safe space. You need because integration tests go in a different direction. You don't need GFG test annotation. However, because unit tests go in the same file as the code, you use GFG test to specify that they should be included. So you usually have the same test in the code and the test together. Not crazy about that. I wish them to be separate. Should take a look at some Rust projects. Testing privates. There's debate in the testing community about whether or not private functions should be tested directly or make it difficult or impossible to test private function. Regardless of which testing strategy you are here, Rust privacy allow you to test private function. Consider using the internal. Okay, so. I don't see them using. Oh, right. This is you specify the public, not the specify only when it's public. Good. Integration test and external to your library. Test directory. There we go. This is the good stuff. That's precisely what you want. Absolutely precisely. I can run a folder. Good. Oh wait, so this is for the integration though. This is some good stuff. This works great. At tests are important to ensure that your code does what you think it should do. Is even. To do import is even using super and everything. Because fuck you. And is to even assert to true, set for true. Actually, it's going to be, is it? Wait, is it? The result is even two, and this is true. I'm sorry, is this not what I'm trying to do? Excuse me, isn't this what we're all about? Alright, this will assert on automatically if it's true. Which means I don't even need this. Good. So 17, 1. Good. 2. Equals the power of 2 using a bit shift. Still going to 2 to the power of n. Okay. This function power of 2 with some value. So power of 2 is going to be 2 and 4. 3 pastes. 1 should be 1. 3 should be 9. And 4 should be 16. Wait, 1 to the power of 2 should be 1. Because the power of 2 using bit shift. It's just the double. Excuse me. 1, 2 is not power of 1. But it's a bit shift, so that's fine. It's times 2. But, dude, this is the power. This is the how big of it. God damn it, I'm so stupid. Let me take a break. I'll be right back. See you soon. Exercise number 3. Actually, let's first check solve test 2. So it will write it out. Nice. So test 3. X test 3. Actually. 3. There we go. I'm gonna be right back, guys. Little bathroom break. That was a good break. Time to get the last 30 minutes going. Then I'll have to to actually go to work as unbearing as it is. So what do we have here? By the way, the last one of this test suite. Yeah. Struct rectangle with height. Don't change this. Returning result would be better here, but we want to learn how to function panic. How to function the panics. So check if the rectangle has the side that we want it to pass. Okay. We should check if the program panics when we try to create. Cert panic. Shoot. Should panic. Bad with bad height. Argument of the expected error message is because to string. No, it isn't. What do you want? Expected non-neg with better. No, it isn't. What do you want from me? No, that's what you mean. Actually, can type with. There we go. Good stuff. So this is fine. 70. That's only 24 to go. I can get this. What's next? Should be iterators. 1. Is there anything about iterators inside of my jam? Here, iterators. Okay, so see, we get a little bit of jumping from here to there. It won't follow the book one-to-one. Closures, iterators, and whatnot. Closure, anonymous function that capture their environment. Closures are anonymous function you can save in a variable or pass as an argument to other functions. Good. And they capture stuff. So go to enum, inventory, options, shirt color, most logged. So giveaway uses a closure. Self shirt color. User preference unwrap or else. Self stop stocked. Yeah, let's go. So num utility and function body. This is what a closure is about. Yep. So closures are anonymous functions. Patrice and Rust. Yeah, I can get this. I don't feel like reading this as of now. Iterators. So without iter. Okay, iter method defined back t. The iterator is stored in v1 iter. Once you've created the iterator, you can use it in a variety of ways. So you can loop over it with a for. We can get the iterator trait and the next method. Every trait iterator is defined in the library. The definition of the trait looks like a type, so my item, and the next, which will always give me the reference to the next object. Yes, because it's a mute self and the return option self item. Not a reference though, a copy. I get a copy. So this solves every problem I had with iterators. I always thought that iterators had to work with the, yeah, it gives a copy. Because in Java, I thought that every time you get the object, you get the object itself. I guess in Java you copy it. Very interesting. So yeah, every time that you get next, you shift the iter. When you call the next method iter directly, I'll return from the repeated calls to next on the beta behavior. This has a number of different methods that default information by the standard library. Sure, methods that produce other iterators. Map, classic. which takes a lambda, by the way. So v-vec2 iter map collect. What does collect do? Fix warning, consume the iterator. Okay, so the warning is dev to the result value. You need to consume and collect method, which is used chapter 2. This method consumes the iterator and collects the resulting value. Collect, which I'm guessing it frees. One standard library provides efficient implementation of the most general purpose programming data structure. This standard implementation should be impossible for to get this out of the way. You should probably just use back on hashmap. Nope, wait. Not collection, collect. Iterator collect. Transforms an iterator into a collection. Collect can take anything iteratable and turn it into a relevant collection. This one is one of the most powerful methods in the standard library, used in a variety of contexts. The most basic pattern which character is used is to turn one collection to another. You can also create instances of types that are not typically collections. Okay, so you are consuming it, but why? No, wait, we're not consuming it, we're just replacing it. This error can basically just goes like that. Fine. Using closure that capture the environment. Choose into iter filter set size shows that collect. Yeah, nothing surprising. Well then, as of today, I don't think I finished this, but let's give it a try. And by the weekend, we should be good to set up my environment. Oh fuck, my tablet is dying fast on me. Not that someone typed, so that's not be a problem, but I wish to know if someone does. When performing operation on an element within a collection, iterators are essential. This model helps you get familiar with the structure of using an iterator and how to go through elements within an iterator. Okay. Alright, create an iterator and lazy over array. Replace to do. So the next would be some custard apple. I mean a reachable statement. Oh wait. My fave fruits dot iter. No. Iter. Good. The avocado is going to be peach. And after raspberry is going to be none. Easy as that. Sol iter one. Sol iter. In this exercise, you learn some of unique advantages that iterators can offer. Complete the capitalize first function hello hello. So none. Let mutable character to the string. Let mut character input to cars. Return first. Capitalize first function to a slice of string, return a vector of string. Hello world, hello world. Uppercase. Okay. Capitalize first word of vector. Apply the capitalize first function to a slice of strings. Return the vector of hello world. So for word in mutable. Actually, it's forward back words.iter. Looks good. And word.cap capitalize. God damn it. Capitalize first. Give him my word. Actually, it's going to be word equals, but this would get mad. It doesn't. No, it does. Expected struct vector unit type. Wait, how is this? For in, for off, iterate, loop, for val in. Mutable word. Add mutable word. Expect the reference found. Expect to the type of this binding. Mismatch expected str found string. Interesting. Can't I just, let's say, do this? Holy fuck, what? What did I just do? Iterators is making this way harder than it's supposed to be. By the way, what the fuck is even this? String? I don't know. And my NeoVim crashed. Why did it crash? Yeah. This. What the fuck am I doing? V1 dot words dot iter dot map. It's going to be string, and this string is going to be string. No, actually capitalize first. If the string dot to string. Actually, not needed. collect. No. Amazing. Apply the capitalize first function again to slice a string, return a single string. So I'm guessing he wants me to use this, but collect, copy, count, flatten. So he wants me to get him flat. Words iter map flatten.collect. So words.iter map, do whatever you want, flatten, collect, should work. Let's see if by telling him explicitly I want a string, then just getting back word. How does this feel? Am I getting crazy, or am I doing precisely what it's written here? Okay, there's also a flat map. The docs are failing me big time. String is not an interactor. This shouldn't be a string what I collect, right? Right, this should be so uppercase plus one str one to end length size width. I actually string that one from all. This works. Doesn't. String input to string. God damn it. To string, motherfucker. What? Collect will auto flatten it? What? Like, see? Crazy stuff. Well, guys, today was a blast. I am absolutely destroyed by how long it goes. So let's take a look at what do my other software developer guys do. Let's maybe eclipse it to English and low to high. Amazing. Blocking bots with block body, Unreal Engine, Twitch extension. Nothing to see here. Well, don't maybe have a good time. Okay. Game engine hacking. Stream to different appear my own mobile game as far. Now that sounds like a title. So I'll be back. God damn it. Is anyone streaming something? Dude, are a bunch of apps all over here. I can always take a Lua. There he is. Please tell me he's here. Dude. This man's running ads on one viewer. Okay, find one. Binary Shrif. Is it gone?